Hello, this is Mr. Wyrick. I'm here to talk to you about Lesson 13.2, the second lesson from Chapter 13, and where things start to get more complicated, but more like what you're kind of used to hearing about or seeing. If you ever look at major sporting events and they talk about calculating the odds that someone is going to win, they'd be using stuff kind of like this. This would be the start of going down that path. So 13.2 is probability with permutations and combinations. So we'll start with permutations. When we're talking about permutations, the order that you are in matters. So if we had to line up to go to lunch, or if we had to line up to select new groups, the order that you are in matters. So there's all kinds of different ways we can make that line, because the order that you put those things in will make a difference. Or if you select 4 people and those 4 people are going to be officers in your group, so you can have a president, vice president, secretary, and treasurer, and those make a difference. You can't just say, oh, well, the secretary does the same thing as the president. So the order that those people are elected in will make a difference. These are situations in which you would use permutations. To calculate the number of combinations that are possible, you use factorial, which is an exclamation point. It's on the calculator. I think, yeah, it's over on the right-hand side by the letters, and it just looks like an exclamation point. You find that exclamation point, that'll work. If you're using one of the 84s, I believe it's in the math menu, and you go over to either the probability menu or the statistics menu when you hit that math button. So that factorial indicates that we are multiplying it by each smaller number. So if we have 4 people that we're going to put in a line, there's all 4 options for number 1, but for the second person in line, there's already somebody at number 1. So there's only 3 options left. And then for the third person in line, there's 2 options left. And then for the 4th person in line, there's 1 single option left. So you take 4 times 3 times 2 times 1. If you go back to our counting principle from the last lesson. Or if there's 5 people in line, then it's 5 times 4 times 3 times 2 times 1. So these work out pretty quick. It's pretty easy to see what's going on there, and you can use the calculator on it. It's quicker usually to hit the factorial button, especially when it's like there are 19 people in the class. How many different ways can we put them together in a line? It's easier to say 19 factorial than it would be to say 19 times 18 times 17 times 16 times 15 and keep listing all those numbers. On page 924, there's permutations with repetitions. I wanted to use a smaller example than they did. So if we take the letters moon, M-O-O-N, and we arrange them in random order, we pull them out of like a bag or something like that, what's the probability that we are going to actually spell moon? We're going to pull them out in the right order. And in this case, since we have 2 O's, we have repetition. So even if we flip these O's, it still spells moon. So we have 4 factorial over 2 factorial. We're going to take 4 times 3 times 2 times 1, and then we're going to divide it by 2 times 1. Okay? And you write it like this still, even if it's easier, just to help you remember however many you're repeating. If you have something like their example in the book where it's Mississippi, where you have like 4 I's and 4 S's, 4 P's, then it would not be 12 factorial. It'd be 4 factorial, 4 factorial, and 4 factorial, because those are not going to come out to the same thing as 12 factorial. So you have to be careful if you have multiple repeated things. I wrote down the page in case you want to take down some more detailed stuff for that. Page 925, they talk about circular permutation. If we have Sam, Bob, and David, and we are going to put Sam, Bob, and David in a line, it's 3 factorial, is the number of ways that we can arrange them. But if we're trying to arrange Sam, Bob, and David into a circle, it's going to be 3 factorial divided by 3. Because if we just take everybody and shift them 1 spot to the left, the appearance of our circle didn't really change. It's not different. It's just rotated. So if we took everyone in our class, we have 19 people in our class, and put them in a line, that would be 19 factorial, would be the different ways we could line everybody up. But if we take everybody in our class and put them in a circle, then that's 19 factorial divided by 19, because there are 19 different ways that we could rotate that circle around and still end up with the exact same circle. Okay? It's not different. The next one is combinations. And when it's combinations, the order doesn't matter. So instead of a line, we're putting you together in our groups of 4. So when you're sitting in your group of 4, the order that you're sitting in doesn't make any difference. So there are fewer ways that we can put you and have it still be something completely different. So in this one, there's NPR, which is number that we're selecting from all of the possible permutations, versus NCR, which is number that we're selecting from all of the possible combinations that there are. Their example is a really good one. If you can only invite 6 of your 20 friends to a party, and you're choosing at random, then it's 20C6. Okay, is how we say that, 20C6. And it would be 6 factorial over 20 minus 6 times 6 factorial. This would be the ways that it would turn out exactly how you want it. Because if you've got 6 friends that you really do want to invite, but you're just drawing names out of a hat, I don't know why you do that, but their example, again, it kind of makes sense for how we want to show this. If you're just drawing names out of a hat, then you could get the first person that you want first, or you could get the first person that you want last, but it doesn't really matter because they're all going to come to the party. So we've got that 6 factorial, all those ways that you can put those people together. And then we've got all the ways that everything can be put together. The full explanation is on page 926. Again, it's kind of lengthy and this video is already kind of dragging on. So do pay attention to that one, check that one over. But probability from combinations is usually, when you do the combinations, you kind of have to make one of those trees or the lists or diagrams, so I don't like to do that necessarily. I can show you tricks how to get that done on the calculator, and there are ways to do it on both the 84 and on our Inspires. So make sure you ask about that when you get to class. We can go over the ways to use the Inspire to get through the lesson pretty quick. You're going to work problems 6 through 26 again. It's going to get you into those higher order thinking, so you're going to have to think about what you do, not just calculate it and throw it together. If you have questions on this, you need further explanation, something doesn't make sense about it, make sure to come in, ask me about it. I've got another book that I can use to kind of explain if we need to do that as well. And if you need any help, again, track me down, find me. I would love to help you on this. This is the last thing we're doing, and it's pretty complicated. So hopefully we'll see you in class. And again, let me know if you have any trouble.